Hello friends, in today's question, a soap bubble is being blown at the end of very narrow tube of radius b. Air having density rho moves with velocity v inside the tube and comes to rest inside the bubble. The surface tension of the soap solution is T. After some time, the bubble having grown to radius r separates from the tube. Find the value of r. Assuming r is larger than b, so that you can consider the air is falling normally to the bubble surface. So let us draw an approximate diagram. So this is our tube and it is given the radius is b, and we have a soap bubble and its radius is given as r, and this angle is of theta. So we are going to surface tension T. Now the air pressure is said to be falling normal to bubble surface, so it will try to push the bubble surface normally in the downward direction, and the surface tension is going to try to hold, or we can say try to balance this particular pressure or force. And the component of the tension that will be try to balance the force and the pressure will be our T sine of theta. So this will be T sine of theta in this part, or another there will be T sine of theta on the other part of the tube. So we can start from here only, and the force of the air is in this direction. So we say that when considering the force due to surface tension, due to the surface tension, it is the component and that component is component of the tension, and that is T sine of theta that acts radially and balances the force due to air. So let us try to find out the force due to surface tension, and we are only interested in the radial component. So we say force due to surface tension and that is a radial component. Therefore we can say that F radial will be equal to T sine of theta, and sine of theta is our B upon R, so we can write that our F radial will be equal to T B upon R. Now this is from only one side, so you can say F radial total will be equal to 2 times this radial force. So we can say F radial total will be equal to 2 times the radial force. And this radial force will be acting along the perimeter of the bubble. Okay. So you can say, write the formula as total radial force along the perimeter of the bubble. So we can just write this as force due to surface tension will be equal to radial force per unit length, radial force per unit multiplied by perimeter of the neck. So we substitute the values. We get force due to surface tension will be equal to 2t b upon r multiplied by 2 pi by b, which comes as 4 pi b square t divided by r. Now we are going to find out the force due to the air which is moving inside the bubble. Say force due to moving air, or we can say thrust force. Force due to moving air, or we can say it as thrust force. And that will be equal to F air will be equal to pressure dynamic multiplied by area of the tube, cross-sectional area, sorry. And the dynamic pressure is given as rho multiplied by velocity square, and we have this as pi b square. So this is our force due to air, and for equilibrium, or we can say it is asked for detachment of the bubble. Yeah. So we write bubble detachment. Our force due to surface tension should be equal to force due to air. We substitute the value. We have 4 pi b square t upon r will be equal to rho v square pi b square, and pi goes with pi, b square goes with b, and from here we get that our r, which we are supposed to find out, will be equal to 4t divided by rho v square. So this is the radius of the bubble. This is the radius of the bubble. And this completes the question. Thank you.